Today we are going to look at Y question June 1998 number 1, which is set theory. And the question says that what A, B, and C are subset of the universal set U, such that the universal set is ranges from 0 to 12. A is set with notation, and B is 4, 6, 8, 10, 12, and C is also set with notation. And we are asked to draw a Venn diagram to illustrate the information and also find this. Let's get started. A solution. The universal set is given as 0 to 12. That is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, then 12. This is our universal set. And set A is a set with notation. From this set with notation, we're going to look at this. It must have the beginning and what ending. And if you look at it, you have to locate the sets first. This first one is not our set. This is our set here. I will divide it into two because I need the beginning of the set and know the ending of the members of the set. Now, if you look at it in your primary school, you used to say your left hand side is less than and the right hand side is greater than. It's not done in that way. This one, you have to consider one thing. You have to locate the set first. Then, when the sign faces the set, it's going to be greater. But when the set is not facing the set, it's going to be less than. So now, S, you can see the sign face what we say as what we consider as our S. This one facing, which means that it's greater. S is greater or equal to what? 0, which means the 0 is inclusive. We are going to start from what? 0 as our starting point. Then I have to know the ending point. Then if you look at it, S is here. It's not, the sign does not face what? The set we consider, which means it's less than. S is less than or equal to what? 7. And the number that is the 7 is also inclusive, which means it ranges from 0 to 7, which means our set A is 0, 1, 2, 3, 4, 5, 6, and 7. We have know our set A, and we also know that set B is not a set with notation. It's very, very easy to us to copy. B is equal to 4, 6, 8, then 10, 12. This is our set B. Then set C is also a set builder notation. And we need to get the starting point and also the ending point. This is our set Y. I divide it into to help to know the starting point and also the ending point. Now S is greater than 1. The number that is greater than 1 is 2. Starting from 2. Then Y is less than what? 8. And the number that is less than 8 is 7. Which means it's 2 to 7. Which means we have 2, 3, 4, 5, 6, then 7. But there's another condition here. Say where Y, this is this set, where Y is a prime number, which means that any number that is not prime here, we're not going to pick it, which means we are going to have 2 is a prime number, 3 as a prime number, 5 is a prime number, 7 is a prime number. So we're going to have 2, 3, 5, then 7 as the prime numbers in the members brackets. So we have A, B, and C. And the first question here says that what? Draw a Venn diagram to illustrate the information given above. You're going to draw a Venn diagram to illustrate this information. So now, but you have to consider and to watch very well before you do any Venn diagram. If you can see, 4 is not here, B and C, they are not that related, even they are not related at all. But if you look at C and A, 2 is here, 3 is here, 5 is here, 7 is here. Which means set C contained in A, which means C is a subset of set A, which means that the circle of set C and A will be in the same place. So now what I'm going to do is that I'll draw a circle. Draw another one inside. Now let's check. Set A, between set A and C, which one have least members? Which means set C have only 4 members, 1, 2, 3, 4. But set A have 2, 4, 6, 8 members. And which means set C contained in A, I'll start with the one that have least members. And which means this one is C, this one is A. Because set A have the big circle here, while set C have a small circle. And what is the, before we move ahead, we have to check what is the intersection between all the three sets. We have 0 here, we have 0 here, no, there's no relationship. Now, we have 1 here, do we have 1 here? No, there's no relationship. We have 3 here, do we have 3 here? No relationship. 4 here, there's no 4 here, okay, there's 4 here, but there's no 4 here. 5 here, there's no 5 here, there's 5 here. 7, there's no 7 here. And if you look at it, in C, we have 2, 3, 5, and 7. That is for C, set C. Then if you look at set A and B, we have 4, we have 6, then we have, what again, nothing. That means set A and B, they intercept. Then I will now draw another one here. This is my B. What is the intersection between set A and B? There's no 0 here, there's no 1, there's no 2, no 3, but there is 4. 4 is the intersection. Then 5, there's no 5, there is 6, which is 4 and 6 is the intersection between what? A and B. But before I make a mistake, I have to cancel out all what I used already. I have used this set 4, I have used 6, I have used 4 and 6 for B. Then I have used all the set for C. I have used this, and this. And from set A, I have used what? 4 and 6 already. Then if I look at it, set C, there's no members of set C again. But set B, what is the set that remain? 8, 10, and 12. 8, 10, and 12 remain, which means we have 8, 10, then what? 12. Then I've used this 8, 10, 12. I'll come back for set what? A. I have 0, 1, 2, 3. I have 0, 0. I've used 1, as you can see. Okay, is there any way I have used 1? No. 1. I've used 0, 1. Now I'll check all the sets I used here. Did I use 2 before? I used 2 before. Yes. Which means I've used it. I've not used it again. I've used also 3 again. So this is the set notation. But the universal set is what? 0 to 12. All the members here must be what? 0 to 12. Did I have 0? Yes. Did I have 1? Yes. 2? Yes. 3? Yes. 4? Of course, yes. 5? Yes. 6? 7? 8? There's no 9. There is no 9. There is, do we have 10? Yes. 11? No. There's no 11. 12? There is. Then the next thing I'll do, I'll draw a circle so that it will contain everything. Sorry, rectangle. It will contain everything. This is the set bigger notation. The element of the set that is not inclusive here, I'll write it outside because you now write it here 9 and what are 11. This is the representation of the data's given, which is set. This is what A. A. Then B part of the question. B part of the question says that what? Find B union C prime. B union C prime is equal to unknown. When you are asked to find something in brackets, what you are going to do is that you have to find what is inside bracket first before you prime it. Prime simply means a not. B union C. B union C. It simply means all the members of B and C. B and C. If you look at it, this is B. And C is this. The members of B and C are 2, because C is this small circle, and this is what? B. B union C, it means 2, 3, 5, 7, if you look at it, you want to choose this one. It's already include what? A, but they talk about B and C. 8, 10, 12. 8, 10, 12. 8, 10, then 12. I'll repeat it again. B union C is when you arrange B and C. B and C. This is C, 2, 3, 5, 7, then 8, 10, 12. So B union C simply means that B union C prime simply mean all these members here, we don't need it in universal set, including because C, if you look at C, B is also inclusive here, 4 and 6 is also there, 4, 6 is there, because if you look at this circle now, this is inclusive, B is inclusive here, which means all B now is this circle, 4, 6, 8, 10, 12 is B. Then C is 2, 3, 5, 7. So this is all the members of B union C. B union C prime means that I don't need all this number from universal set, which means that from 0 to 12 now, there's no 0 here, we need it, 0. Do we have 1 here? No. 2, yes, we have it, don't need it. 3, we don't need it. 4, we don't need it. 5, we don't need it. 6, we don't need it. 7, we don't need 8, but there's no 9. Then 10, we don't need it. 11, do we have 11 here? No, which means we need 11. Then 12, do we have 12 here? Yes, we don't need it. This is B union C prime. Then the third question says that what? A prime intersection B intersection C. First of all, we have to find A prime. A prime. A is what? A is already 0 to 7. 0 to 7. 0, 1, 2, 3, 4, 5, 6, 7. Then A prime simply means we don't need all this number from universal set. We have we have 8, 9, 10, 11, 12. This is A prime. Then we have to find B intersection C. B intersection C, which means where B and C relate, where they combine together. B and C. Look at B. There's nowhere they intersect, which is empty set. There's nowhere they intersect here, which is empty set. Empty set. Then A prime intersection B intersection C is equals to all this member, any number intersection empty set is still empty set, which means the answer is empty set. Thank you and peace out.